Complete the following nuclear equations and identify X in each case. For A, we're going to start off with the reactants of iodine, which has number of protons of 53 and a nuclear mass of 135. And the products is xenon, which has 54 protons and a nuclear mass of 135. We're trying to solve for X. First, we're going to focus on the protons. And to find out how many protons X has, we're going to divide the number of protons of reactants by the number of protons of products. Therefore, we have 53 minus 54, which will give us -1. And then we're going to focus on the nuclear mass of the reactants and the products. We're going to start off with 135 and subtract 135, leaving us with a difference of 0. Therefore, X will have -1 number of protons and a nuclear mass of 0. This will then be beta. Now for B, the reactant is potassium that has 19 protons and a nuclear mass of 40. And the products are beta plus X, and beta has a -1 protons and no nuclear mass. Therefore, we're going to start off with the protons again, and it'll be 19 subtracted, and subtract -1 protons, which will then give you 20. And now we're going to focus on the nuclear mass, which is 40 minus 0, which equals 40. Therefore, X has 20 protons and a nuclear mass of 40. So if you look on the periodic table, you find that calcium is what matches the number of protons, because the number of protons is also the number on the periodic table. Now for C, on the reactant side, you have cobalt that has an atomic number of 27, also 27 protons, and a nuclear mass of 59, added with a neutron that has a nuclear mass of 1 and no protons. And on the product side is manganese that has an atomic number of 25 and a nuclear mass of 56 plus X, which we're trying to solve. So let's start off with protons. We have 27 plus 0 on the reactant side. Subtract 25 on the product side, and you get 2. Now for the nuclear mass, you have 59 plus 1 on the reactants, and you subtract 56. That will leave you with a nuclear mass of 4. Therefore, X has 2 protons and a nuclear mass of 4, and it is alpha. For D, you can immediately see that X is multiplied by 2, so therefore the procedure is similar but a little different. You're going to, again we're going to focus on the protons. On the reactant side, it's 92 plus 0, and on the product side, it is 0 plus 52. I'm sorry, zirconium has 40. This is 40. So therefore, it's 40 plus 52. And that will give you a total of 0. Now, since it is multiplied by X is multiplied by 2, you're going to divide it by 2, and it will give you 0 protons. Let's move on to the nuclear mass, which is on the reactant side 235 plus 1, subtracted, and you subtract 99 plus 135, and that will give you a difference of 2. However, x is multiplied by 2, so you divide it by 2, and your nuclear mass is 1. So therefore, X has a nuclear mass of 1 and 0 protons, and it is a neutron.